Welcome to the DIY Honda Garage channel. The DTC P0711 indicates an issue with the continuously variable transmission, CVT, fluid temperature sensor. This sensor monitors the temperature of the CVT fluid, which is essential for optimal transmission performance and component longevity. When the temperature readings fall outside the specified range, this code is triggered. It's important to note that the fault is related specifically to the electrical circuit of the sensor and is not caused by any mechanical transmission problems within the vehicle. The sensor is located in the transaxle assembly and plays a critical role in ensuring the CVT operates efficiently under various temperature conditions. Before proceeding with the diagnostic steps, the general troubleshooting information must be reviewed to ensure accurate diagnosis and effective repairs. The DTC P0711 specifically refers to the continuously variable transmission fluid temperature sensor, which is responsible for measuring the temperature of the CVT fluid. This measurement is crucial for the vehicle's engine control module, PCM, to adjust shifting patterns and optimize performance. The sensor is positioned within the transaxle assembly, a central hub for the transmission system, where it continuously relays temperature data. Proper function of this sensor ensures that the transmission fluid remains within optimal temperature ranges, thus preventing overheating or underheating. Should the sensor fail or report incorrect data, it will activate the DTC, alerting the driver and technician of potential underlying issues. Troubleshooting solutions focus primarily on verifying the sensor's performance and rectifying any electrical circuit problems. Various factors can trigger the DTC P0711, starting with a faulty transmission fluid temperature sensor. If the sensor does not respond accurately, the PCM may receive incorrect readings, leading to suboptimal performance. Wiring issues, such as frayed wires or poor connections, can also disrupt the signal sent to the PCM. Inspecting the wiring harness and connectors for signs of damage is vital, as even slight wear can cause malfunction. In rare cases, a faulty PCM itself may contribute to this DTC, especially if it fails to interpret the sensor signals correctly. Consequently, ensuring all components in the temperature monitoring system are functioning properly is crucial for resolving the P0711 code. Attention should be paid to the electrical components throughout the troubleshooting process. The symptoms associated with the DTC P0711 can manifest as various performance issues. Drivers may experience erratic shifting behavior, where the transmission fails to shift smoothly between gears. Additionally, the vehicle may show signs of engine performance issues due to improper signals sent from the temperature sensor. Overheating of the transmission can occur if the fluid temperature information is not accurately reported, leading to potential mechanical failures. Drivers may also notice warning lights illuminating on the dashboard. Recognizing these symptoms early can prevent further damage and warrant immediate inspection. It's imperative for technicians to be aware of these warning signs when diagnosing the P0711 code, as they indicate the need for thorough examination of the CVT components. Step 1 in the troubleshooting process for DTC P0711 involves checking the current transmission fluid temperature using the Honda Diagnostic System, HDS tool. Initially, the vehicle should be turned to the on mode, allowing the HDS to read live parameter data. It is essential to evaluate the CVT fluid temperature, which should register below 14 degrees Fahrenheit or -10 degrees Celsius as a baseline. If the recorded values during the check do not match this threshold, further investigation is needed, and the technician should move to Step 3. However, if the conditions are confirmed to be within the specified range, you should proceed to Step 2 for a more thorough analysis of the transmission fluid temperature sensor. In Step 2, the technician starts the engine and allows it to warm up until it reaches normal operating temperature, which is indicated when the radiator fan cycles on twice. Using the HDS, the technician will again check the CVT fluid temperature, ensuring it falls within the threshold of 14 degrees Fahrenheit or -10 degrees Celsius. If the reading is, in fact, greater than this threshold, it could indicate a faulty transmission fluid temperature sensor, warranting replacement of both the sensor and its associated solenoid wire harness. Conversely, if the CVT temperature reading is still below these points, the sensor may still function intermittently, prompting the need to check for poor electrical connections or loose terminals, rather than immediate replacement of parts. This step is critical for determining the need for more extensive diagnostic measures. In troubleshooting Step 3, the technician must verify the parameters once more using the HDS. This involves checking the CVT fluid temperature to see if it exceeds the threshold of 230 degrees Fahrenheit or 110 degrees Celsius. Such a high reading indicates a duplicated failure, confirming the existence of an issue that requires further steps. Should the readings not match these parameters, the next best action involves updating the PCM software if it's outdated, or substituting a known good PCM. This substitution is crucial to ascertain whether the PCM itself is at fault and to ensure the vehicle returns to normal function. If the update resolves the issue, no further action is necessary. If the substitution resolves the DTC, you'll need to replace the original PCM permanently, ensuring long-term reliability of the vehicle's transmission system. Troubleshooting Step 4 requires letting the engine cool down until the engine coolant temperature reads 122 degrees Fahrenheit or 50 degrees Celsius or lower. This cooldown phase allows for accurate assessment of the CVT fluid temperature without heat-induced anomalies. The technician will again check the CVT temperature using the HDS, looking for readings to confirm whether they exceed the 230 degrees Fahrenheit or 110 degrees Celsius threshold. A reading above this indicates a faulty transmission fluid temperature sensor, leading to the need for solenoid wire harness replacement. Should the readings show temperatures at or below this threshold, it suggests the sensor is functioning within optimal parameters. At this point, the technician should investigate potential causes of intermittent failure by checking for poor connections or loose terminals between the temperature sensor and the PCM to finalize the diagnosis. After the troubleshooting steps have been completed and any necessary repairs made, it's essential to conduct a final repair verification by test driving the vehicle. During the test drive, closely monitor the vehicle's performance, ensuring that the previously noted symptoms, such as erratic shifting and unwanted warning lights, do not return. Technicians should also use the HDS to scan for any DTC reappearance, specifically for DTC P0711. If the DTC does not reappear and all systems operate smoothly, it can be concluded that the repairs were successful. However, if the problematic DTC resurfaces, further diagnostics are required to rebuild confidence in the repairs and isolate other potential factors that may be affecting performance. Implementing preventive maintenance can help mitigate the risk of encountering DTC P0711 in the future. Regular checks of the CVT fluid temperature should be part of a comprehensive maintenance routine. Technicians should also ensure that software updates to the PCM are completed as soon as they are available, minimizing the risk of discrepancies in information processing. Furthermore, routine inspections of all electrical connections and wiring associated with the transmission fluid temperature sensor can catch issues before they escalate into critical faults. Performing these preventive measures not only enhances longevity of the transmission system, but also improves overall vehicle performance. Making these checks routine will contribute significantly to vehicle reliability and safety. In summary, addressing DTC P0711 involves understanding the role of the transmission fluid temperature sensor and closely monitoring the entire electrical circuit surrounding it. The troubleshooting steps focus on confirming accurate temperature readings, verifying the functionality of the PCM, and ensuring connections are secure. Recognizing symptoms early can steer technicians towards swift and effective solutions, reducing the risk of more significant transmission issues. Additionally, implementing a standardized preventive maintenance routine can greatly enhance the longevity and performance of the vehicle's CVT system. By following these guidelines, vehicle owners and technicians can work together to maintain the health of their Honda Fit's transmission system. Please like and subscribe to the channel. See you next time.